All right, here we go. 7.4, the homework was 440 to 441, 2 to 44, every other even, and I'm going to do 1 through 41, every other odd. All right, remember this is adding and subtracting radicals, and I told you guys to treat the radicals as if they were x's, and use the same rules that you use when you're talking about variables. So we have the square root of 8 minus the square root of 32. Now we know that in order to be able to add or subtract radicals, you have to have the same index and the same radicand, which differs from when you're multiplying and dividing radicals when you only need the same index. So in this case, it looks as if we can't subtract these because they don't have the same radicands. But in order to decide fully, we need to simplify each one and then see if we can add or subtract them. So let's make our factor tree. 8 is 4 times 2. 4 is 2 times 2. Since the index is 2, we need a repeat of 2 in order to pull one out front. And then I box what's ever left over. So I have 2 square root of 2 minus, now let's do 32. 32 is 8 times 4. 8 is 4 times 2. And 4 is 2 times 2. And over here, 4 is 2 times 2. Now cross out whatever you simplified, that way you don't get confused with what's left. So I've got a pair here, and then I have 1 left over. So that means I can bring out 1, 2 2's. So 2 times 2 is 4, and then I've got a 2 left under the root. Now I have the same index and the same radicand, so therefore I can go ahead and just add or subtract my coefficients. So it's 2 minus 4 is negative 2, and then you keep the square root of 2. And that is your answer. Okay, now we have 2 square root of 50 minus 3 square root of 125, and that says plus the square root of 98. Sometimes it doesn't work right. Okay, anyway, so I'm going to go ahead and simplify each piece and see what I can do from there. So 50, I'm going to simplify to 25 and 2, and then 25 is 5 and 5. So don't forget that you've got this 2 out front. So I have a 5 and a 5. That's going to go out front. And then this 2 is going to stay on the inside because that's all I have left. So the original 2, this one here, times, I brought a 5 out front, and then what I left behind was square root of 2. And you can go ahead and clean this up. It ends up being 10 square roots of 2 because 2 times 5 is 10. All right, minus. Now I know I'm going to have a 3. So make sure you don't forget about that. And then 125 I'm going to break down is 25 and 5. Excuse me. And 25 is 5 and 5. So I can bring a 5 out front and a 5 stays inside. But don't forget, originally I had that 3 from all the way up here. And so times 5, and then the root's going to be 5. So 3 times 5 is 15. Square root of 5. And then 98, what times what is 98? 49 and 2. And then 49 is 7 and 7. So 2 7s can come out front. And then a 2 is going to stay on the inside. So then this is going to give me plus 7 square root of 2. Okay? So now we've got everything simplified as far as it can go. So now we need to see if there's anything else we can add or subtract together. So remember, has to be the same index, has to be the same radicand. So they all have an index of 2, because don't forget your index is the number that's right here. And if there is no number there, it's always an assumed 2. And then your radicand is the number underneath. So yes, all of my indexes are the same. However, only this radicand and this radicand are the same. So I can go ahead and add or subtract these 2 coefficients. So let's go ahead and slide our screen up some. And so I can do 10 plus 7 is 17. And then we've got the square root of 2. So I took care of that. I took care of that. And then I've got minus 15 square roots of 5. Because they're different radicands, there's nothing else that I can do with it. So that is my final answer. It would be just like at the end if you had x squared plus x. Because they're not like terms, you cannot add them together, so we just stop there. Okay, here we have the square root of 9b cubed minus the square root of 25b cubed. And again, I can't see if is that plus or minus? It's plus. Okay, so that's a plus there. All right, so we got to break each one up. First off, I know that the square root of 9 is what? Square root of 9 is 3. So I know that's 3. And then I have the square root of b cubed. So remember, you've got this 2 here that you can take to the back and make your denominator. How many times does 2 go into 3? It goes in 1 time, which means you can bring a b out front. And then how many are left over? 1b, so you're left with that b inside. Minus, we know the square root of 25 is 5, so just the square root of 25 is 5. And then same as before, when I have b cubed, I'm going to take this 2, make your index your denominator. Remember the saying I said, die. 2 goes into 3 1 time, so 1b can come out front, and then the other b is left inside. Ignore that little mark right there. Okay. There we go. Plus, we know the square root of 49 is 7, so we bring the 7 out, and then again, exactly like before, you take your index to make it your denominator. And then you say 2 goes into 3 1 time, which means 1 comes out front. And then you have 1 left over, so that stays inside. Now, they're all the same index. They all have an assumed index of 2. And they're all the same radicand. So I can add or subtract all of their coefficients. Excuse me. So I've got 3b minus 5b plus 7b. 3 minus 5 is negative 2. Plus 7 is 5. So you have 5b square root of b. And that is your final answer. Okay, now we're dealing with some fractions here. We're going to go ahead and use the quotient rule. So that's going to make our life a heck of a lot easier. So instead of the cube root of 11 over 8, I'm going to do the cube root of 11 over the cube root of 8 minus the cube root of 11 over 6. And the reason I did that is because the cube root of 8 is 2. So anytime we can get rid of a radical because we can simplify it because it's a perfect cube or perfect square, we should go ahead and do that. So this, we're just going to change to a 2 because we know the cube root of 8 is 2. So then our problem's going to become the cube root of 11 over 2 minus the cube root of 11 over 6. Okay, so it's pretty being that we have the same numerator, so later on we know we're going to be able to subtract our numerators. However, when you're talking about fractions, you need what? You need a common denominator. So let's find our common denominator. We need a common denominator between 2 and 6. So the smallest number that both 2 and 6 go into, it's going to be 6. So since this denominator over here didn't change, we're just going to keep the numerator, which is cube root of 11. And then cube root of 11 over 2, I need it to be over 6. So this is how I look at it. I say bottom goes into bottom, how many times, and then times the top. So 2 goes into 6 3 times, and then 3 times the cube root of 11 is 3 cube roots of 11. I know some people go like this. I need the 2 to be a 6. In order for the 2 to be a 6, I need to times it by 3. So then I need to times it by 3. Because whatever you do to the bottom, you have to do to the top. Either way, you're going to get to the same place. So now I have 3. Oh, I broke it. I don't know how to fix that, so we're just going to keep going. 3 cube roots of 11 minus the cube root of 11 all over 6. So I'm going to put everything over 6, and then I've got 3 cube roots of 11 minus the cube root of 11. Okay, so you know your answer is going to be over 6. They have the same index. They have the same radicand, so we can subtract them. Don't forget, you're going to go ahead and subtract or add your coefficients Well, there isn't a coefficient right here, right? It would go right in front of this tiny 3, our index. But just like if these were x's, we're going to go ahead and assume there's a 1 there, right? So then this would be 3 minus 1, which is 2. And then you just put on your cube root of 11. Because this and both of these two numbers are not inside a radical, we can reduce them. So 2 over 6, we're going to reduce to 1 over 3 by dividing both of them by 2. So our final answer is going to be the cube root of 11 over 3. All right, so let's see what this problem actually says. All right, so this is a plus, guys, right here. I don't know what's up with that. It keeps sliding over on the PowerPoint. Sorry about that. All right, so let's go ahead and see if we can add these or subtract these, but in order to do so, we need like indexes and like radicans. So first off, they were very nice to us in this situation because we know the square root of 9 is 3. So this becomes 7 times 3 plus 7 plus the square root of 3. So 7 times 3 is 21 plus 7 plus the square root of 3. We can't reduce or simplify, the square root of 3 any further. So I'm going to say 21 plus 7 is 28 plus the square root of 3. And unfortunately, we can't take that any further. So I'm going to go ahead and circle it, and that's it. Okay, so comparing that answer to the book answer, it is incorrect because the problem was wrong, was typed in wrong. So I'm going to go ahead and leave that, but I'm going to erase really quick. And, oops. There we go. And we can go ahead and do, the book problem says that it's minus right here. So it's 7 square root of 9 minus 7 plus the square root of 3. So I'll go ahead and do that one too. So again, square root of 9 is 3. So 7 times 3 is 21 minus 7 plus the square root of 3. 21 minus 7 is 14 plus the square root of 3. And that's as far as you can go. And that's actually the book question. So that was my mistake. I had a plus in there. It was supposed to be a minus. Either way, done the same way. Okay. All right, 21. So let's check to make sure it's the right question. 3 square root of 108 minus 2 square root of 18. And this is a minus 3 square root of 48. Okay, so none of those are perfect squares. So we're just going to go ahead and have to start simplifying. Now, what's very important in these situations, when you're going to have to simplify and then go further, always remember your numbers that are out in front. It's real easy to forget those. Also, always make sure you're paying attention to your signs, because out of habit, we just want to always add. But a lot of times it's minus, so make sure that you're paying attention. Good attention to detail. All right, so we have 3 square root of 108. So 108 is what times what? Well, it's 54 times 2. And then 54 is 6 times 9. And then 6 is 3 times 2. And 9 is 3 times 3. Cross off what we've already simplified so we don't get confused. All right, don't forget about this 3. And in order to pull stuff outside, I'm going to need 2 of them this time. So I've got 1, 2 2s, 1, 2 3s, and I've got a 3 being left behind. Okay, so that leaves me 2 times 3, and this is where I'm getting these numbers from. I've got 2 2s, so I'm pulling a 2 out front. I've got 2 3s, so I'm pulling a 3 out front. And then I've got this original 3 from the very beginning of the problem that that's also being multiplied out front. And then what's left is just the square root of 3. Okay, now let's just go ahead and write minus so we don't get mixed up later. Now I've got 2 square root of 18. 18 is 9 and 2, and 9 is 3 and 3. Okay, so I've got this 2 that's going to be out front, and then I've got 2 3s, so that brings 1 3 out front, and then I've got a 2 left, so it's going to be the square root of 2. All right, minus, so I don't forget later, and then I've got 3 square root of 48. 48, 6 times 8 is 48. That's my favorite one. And then 6 is 3 times 2, 8 is 4 times 2, and 4 is 2 times 2. Cross off everything so you don't get confused. Don't forget about this 3. I'm going to write that first. And then I need 2 in order to bring it out front. 1, 2, bring a 2 out front. 1, 2, bring another 2 out front. And I've got a 3 left over, so I'm going to put him there. It's a lot going on, right? It's all right. It's all simple math that we can handle. Okay, so first, 2 times 3 times 3. So 2 times 3 is 6. 6 times 3 is 18. Times the square root of 3. Minus 2 times 3 is 6. Square root of 2. Minus 3 times 2 times 2. 3 times 2 is 6. 6 times 2 is 12. Square root of 3. Now remember, index and radicand have to be the same. All my indexes are an assumed 2, so we're good there. But my radicands are not all the same. This radicand and this radicand are the same, which means I can take this term and subtract them. So I'm going to say 18 minus 12 is 6, square root of 3. So I took care of this and I took care of this. Minus 6, square root of 2. I can't go any further because though my indexes are the same, my radicands are not. So this is 6 square root of 3 minus 6 square root of 2. Moving on to 25. 25, I've got square root of 9b cubed minus the square root of 25b cubed plus the square root of 16b cubed. All right. Very similar to one of the ones we did earlier. This is a plus sign here. So again, what is the square root of 9? It's 3. And then the square root of b cubed, remember, take your index, make it your denominator. 2 goes into 3 one time. That means I can bring 1b out front. And then there's 1 left over, leaving 1b behind. Remember, the amount of times that your index can go into your exponent is how many b's or how many variables you can bring out front. And then how many are left over after you take all of those out are how many variables will stay inside the radical. All right. Minus the square root of 25 is 5. And then again, b cubed is going to end up being b square root of b, just like it was here. Okay, nothing changed. B cubed, I brought a b out front, I left a b inside. B cubed, brought a b out front, kept a b inside. Plus, we know the square root of 16 is 4. And then just like before, b cubed had a b outside, kept a b inside. B cubed had a b outside, kept a b inside. And then b cubed brought a b outside, kept a b inside. Now, because our indexes are all the same and our radicands are all the same, we can add or subtract them. So we have 3b minus 5b plus 4b. 3b minus 5b is negative 2b plus 4b is positive 2b. So it's 2b square root of b. Or not to be. Oh man, I'm funny. All right, this is a plus sign. 29, cube root of 54xy cubed minus 5, cube roots of 2xy cubed plus y, cube root of 128x. All right, this one looks fun. So, because all of our indexes are 3, this time when we simplify, we need to make sure that we have a repeat of 3 before we can pull something out front. So 54, cube root of 54 is going to be 54 is 6 times 9. 6 is 3 times 2. 9 is 3 times 3. Okay? Cross out the things we already did. And remember, I need 3 of them because my index is 3. 3 repeats. So I have 1, 2, 3. So I know 3 is going to come out front. And then I'm going to leave a 2 inside. And I'm going to leave a little space right here because I still have variables in this root to deal with, and some of those could come out front. Okay, so now let's deal with the x. There's only one x right here, and I would need 3 to repeat in order to bring one out front, so it doesn't make any sense for me to even try to imitate or simplify that. That x is staying inside. And then I have 3 y's, and I need 3 in order to pull it out front, so that just means it's a perfect cube. I'm going to go ahead and just bring a 3 out, or a y out front. So cube root of 54xy cubed ended up being 3y cube root of 2x. Minus, don't forget about this 5, okay? I'm going to write it there just so I don't forget about it. Now, cube root of 2, I can't clean that up at all. Because it's just a 2, I can't simplify it any further. And just like my x, just like before, there's only one of them. So you know that's going under the root. So we know we're going to have a cube root. We know it's going to have a 2 and an x under it. And then just like in the previous term, I've got 3 y's. 3 is how many I need to bring out front. So my y is going to come right up front. All right. So then I've got plus. Good, we're going to break down 128. We know for a fact that we're going to have an x under our radical because there's only one x in here. And you know you're going to have a y out front because there's already a y out front. So I'm going to put a y here. And then I'm going to put cube root of something x. Who knows what's going to go in front of it? Let's hope for a 2. Because then that would make all of our radicands match. But who knows if that'll work. So 128. I have no idea the factors of 128. It's an even number, so the easiest thing to do is divide it by 2. So that is 64 times 2. And then 64 is 8 times 8. They're terrible 8s. And then 8 is 4 times 2, and 4 is 2 times 2. Here, 8 is 4 times 2, and 4 is 2 times 2. All right, we need 3 to be able to bring one out front. 1, 2, 3. 1, 2, 3. So I can bring 2 2's out front, which would give me 4. And then that 2 we were hoping for is there, which makes our life a heck of a lot easier now. Now, if I'm going too fast, you can always pause the video and rewind it a little bit and listen again. That's the nice thing about these videos. Okay, now my indexes are all 3. My radicands are all 2x. So that means I can add or subtract all of my coefficients together. So I'm going to say 3y minus 5y plus 4y. 3y minus 5y is negative 2y plus 4y is positive 2y. So I'm going to have 2y cube root of 2x. Once you add or subtract the coefficients, you just throw on the index, the radical, and the radicand, and you are good to go. All right, 33 says negative 2 fourth root of x to the 7th plus, this is a plus, guys, 3 fourth root of 16x to the 7th. All right, so like I said before, you have a negative 2 out front and you have a 3 out front here. Don't forget about those. My indexes are 4, which means at the end, no matter what, I'm going to have a 4 as an index. And that also means that I need something to repeat 4 times before I can bring it out front. So I'm going to start by writing my negative 2 so I don't forget about it. I'm going to take my index and make it my denominator. And I'm going to ask myself, how many times does my index go into my exponent? 4 goes into 7 one time. So that means I can bring 1x out front. And then I've got the 4th root. And how many are left over? We only used 4 of the 7, so 3 are left over. So that means you put x cubed inside of the root. And remember, you could always go 1, 2, 3, 4, 5, 6, 7. And then go 1, 2, 3, 4. That means I can bring an x out front. And then 1, 2, 3. Those are supposed to be squares, just in case you're wondering. That's how many stay inside the radical. So either way you want to do it is fine. Plus 3, because we already started with this 3 right here. Okay. And we've got the 4th root of 16. Okay. So the 4th root of 16, I'm going to bring it over here so you guys can all see what I'm doing. Okay. 16 is 4 times 4. 4 is 2 times 2, and 2 times 2. Okay? So 1, 2, 3, 4. I'm obviously going to bring a 2 out front. And then just like x to the 7th over here, x to the 7th here means I'm going to bring 1x out front. Sorry, I was trying to figure out how to erase something, and apparently I have no idea what I'm doing. So we'll just ignore it. Okay, so I'm going to bring an x out front. And then I'm going to leave 3 x's on the inside. So it's the 4th root of x cubed. Now let's clean that up a little bit because this is a hot mess. So right now I have negative 2x, 4th root of x cubed, plus, we can clean this up, 3 times 2 is 6x, 4th root of x cubed. Okay, so let's check to see if our index and our radicands are the same. Index the same. Radicands the same, so I can go ahead and add or subtract the coefficients. So I have negative 2x plus 6x is positive 4x, and then it's the 4th root of x cubed. And that's your answer. Okay. Right. Ooh, fun, more fractions. Oh, but this one's easy. They already gave us a common denominator. Okay, so normally when they give us fractions, we have to do a quotient rule in the beginning, but this one we don't have any radicals in the denominator, so we can go ahead and write everything over the same common denominator, but I strongly suggest that you simplify the numerators as much as you can first. So for instance, we know that the cube root of 8 is 2. So I'm going to change cube root of 8 to 2. And then if we take our index and make it our denominator, and we ask ourselves how many times can the index go into the exponent, 3 goes into 4 one time, and that represents 1x coming out front. And then we have the cube root of whatever's left. If you use 3 of the 4, how many are left over? Just 1x. That was supposed to be an x. Okay? Plus, this is already simplified as much as possible. So we're going to say 3x cube root of x. And I'm going to write all of this over 7 because it's a common denominator. Now, because both of these indexes and radicands are the same, I can go ahead and add these coefficients together and clean this up a little bit. So 2x plus 3x is 5x cube root of x all over 7. And nothing here simplifies because 5 and 7 cannot be reduced any further. Okay, so we can't reduce that anymore. Last one. This is an example of what I was just talking about. Normally we have to do the quotient rule on these types of problems, so let's go ahead and do that. Quotient rule says I can take this cube root of the entire fraction and break it up into the cube root of the numerator over the cube root of the denominator, which is what I've done here. And then I've already got the cube root of 54, and then it's just 6 in the denominator over here. So, a couple things. We need to simplify. We know the cube root of 27 is 3, so we can go ahead and change that to 3. And cube root of 16, not a perfect cube, so I'm going to bring 16 over here and break it down and see if there's anything I can do with it. It's 4 times 4. I know how to multiply. And then 4 is 2 times 2, and 2 times 2. So in order to bring something out front, I need 3 of them in this case. So this is going to become 2 cube roots of 2. I brought a 2 out front and I left a 2 on the inside. So this is going to become 2 cube roots of 2 all over 3 minus the cube root. Well, let's see if we can do anything with 54. 54 is 9 times 6. 9 is 3 times 3. And 6 is 3 times 2. So we can simplify this. I'm going to bring a 3 out front. Haha, turns out I do know how to erase. So I'm going to put a 3 here, and then it's cube root of whatever's left over, and that's a 2. All over 6. Okay, now I need to find a common denominator. I need a common denominator between 3 and 6. The lowest number that both 3 and 6 go into evenly, it's 6. Since my denominators here stayed the same, I can go ahead and keep my numerators the same. So this is 3 cube roots of 2. And then here, you're going to say bottom into bottom times top. So 3 goes into 6 2 times. 2 times 2 is 4. And then you've got the cube root of 2. Or, remember I said some people like to go like this. In order to make 3 6, I have to multiply by 2. So then just multiply both the numerator and denominator by 2, and that's easier for some people to see. Now I'm going to put all this over one common denominator of 6. And then I've got 4 cube roots of 2 minus 3 cube roots of 2. Because they are the same index, and radicand, I can go ahead and subtract their coefficients. In this case, it's 4 minus 3, which is 1 cube root of 2 over 6. We don't normally write the 1, so I'm just going to clean it up and make it the cube root of 2 over 6. Now, don't you dare attempt to reduce this 2 and this 6. You cannot do that. Also, don't get fancy and try to reduce the index with the 6. No. This is the answer. You can't go any further. All right, and I think that is all for this one. Hope you guys are having a great spring break.